people come in like 5 minutes late. But we're going to start the section. It's going to be the fall protection, which is in CHST, ASP, and CSP, and we're going to talk about working at heights, and not going to talk about scaffolds and ladders except for one part of the issue. And then we got some study questions on the thing. Again, the questions that I show here are not from the real exam. I reword the questions, so I don't use the actual question, but I take the concept. And we're going to talk about working at ladders and heights. And the first thing we got to talk about is, where do we wear our fall protection? Do we wear it in the middle of the back for the D-ring, or do we wear it at the lower waist, or other spots? And hopefully, you would know that it's in the middle of the back. So he's tied off, and he's got a double lanyard, and he's tied up to the guardrails. The problem with that is guardrails are designed to hold 200 pounds. They could hold more, but your fall arrest anchorage has to be able to hold a fall if that person was to fall off the scaffold. And if it's a design with just a clamp at the end over here, that's not going to hold 5,000 pounds. That's not probably even going to hold 1,000 pounds. So more likely he just breaks off the top rail and he goes down. And this is the trouble, because people are using things that they get, and if they don't have it designed for them and it hasn't been thought out, then people get into the predicament. And so, the outcome is, it's in the CHST, it's in the ASP. If you go to the blueprints for these, it's be domain 2 for the ASP, and it's knowledge item 12. And they call it walking working surfaces. And then CSP is knowledge item 4. Again, these items are going to be part of it. Fall is usually 5 to 10 questions on some of these exams. The big one is this hierarchy of fall protection. It's not OSHA, but it's the idea that we want to try to eliminate the fall in the first place. So if we can use a stick to go in there with a clamp or a grabbing device to change the light bulb, we don't have to have a fall, therefore we're not on a ladder, therefore we're not going to fall. Passive fall protection is our guardrails. It's there. It prevents you, if it's done right, from falling off to the lower surface. So that's what they call passive term, and that's a term that OSHA does not use. They just use, guardrails are a method of fall protection. Restraint is, we're going to get to the edge, but we're not going to be able to fall off the edge, because we know the length of the lanyard to the edge of the roof, and we're going to make it shorter. So it's kind of like the dog on the leash. The dog can't go any further than the leash is, and that's what you're going to be. And it works if it's done right. Then we're going to fall off the edge, or lower height, and now we're going to have something that's going to arrest or stop our fall safely. And the anchorage has to be about 5,000 pounds, or a safety factor of 2 designed by a competent person. Or the fall force can only be with a body harness at 1,800 pounds of fall force. You don't have to worry about that. The companies that make the harnesses and the lanyards will always tell you the maximum fall force, and the industry standard is 900. And then we have things like warning line systems, safety monitors. Those are administrative controls. It's trying to make sure that you are hopefully having somebody watch you and you're not going to fall off the edge, but really there is nothing there to prevent you. It's just somebody going to watch you, or administrative controls. So this is always going to be on the test in some form or another, 1, 2, or 3 questions of it. And then the fall protection in OSHA, and again, these are numbers that OSHA has. Industry is 4 feet, construction 6 feet, and if you're on a scaffold, it's 10 feet. If you're doing steel erection, it's going to be 15 feet. And if you're on a ship and longshoring at the docks, it's 8 feet. So these are all different numbers made by different groups. And when OSHA started in 1971 and made standards for the first year, they took these industry rules and made them law. You would think they would have just one number, but nobody wants to go over and give that that number to that person and stuff. So here we got a guardrail. The guardrail is going to be 42 inches. We got our ladder hatchway. We got an issue with the ladder. The first thing I'm going to tell you that I see with this is the ladder has to be at least 7 inches away from the surface, because you're not going to be able to get your foot onto the rung if it's so close to the wall, and that's not good. So the travel restraint common system, you're going to do some work. You got the length of the lanyard measured out. They can't get to the edge. It's a good system. It doesn't require much. The anchorage is going to still be 5,000 pounds. They're going to use what they call davits. This is what these poles are in the middle of the roof. They're connected to steel or concrete. They're going to hold quite a bit of weight. They've got all the skylights guarded, which is a requirement because skylights are floor holes by OSHA. Here's another one. He's got it over here. He's on what they call the green roof, where you can go out and plant, grass and everything else on the roof to take off the solar load. Again, he's not going to fall off the edge, and that's what we want to do. So it's a higher priority than actual fall arrest. And then fall arrest systems are going to be designed to make sure that it rests you softly. It's going to have a lanyard, it's going to have a body harness only, and then it's going to have a retractable or a fixed lanyard. And you're not allowed to use a body belt whatsoever if there's a fall arrest or you're going to fall, because it would destroy your insides. The administrative controls are a last resort. That means you're going to set up a warning line system. That means a worker in flat roofing. They came up with this in 1977 because it wasn't a way to protect the workers with positive fall arrest. Today there is. So they set up warning lines 6 feet away. If you had mechanical equipment, it would be 10 feet away. And these warning lines would have a monitor watch you work. Nothing prevents you from falling off the edge. The idea is that if they see that you're going to step on a tool or something, they could tell you, hey, Joe, you got to watch out. You're going to step on a tool. That's what the warning. So it's administrative. It's the least desirable. So which one of these is considered passive fall protection? Now, if you go to the chat, you can type in the answer, just A, B, C, or D. Fall arrest, rope grab and a rope, guardrails, or descent control. We'll go for a couple answers here. Okay, very good. C is guardrails. And I also, people who watch this video will be able to go in there and take it kind of as they go through it. So body belts just go around your waist. You can imagine if you just fell with this, it'd be no different than having a belt on and just hanging there. People couldn't even hang into a belt because it hit their waist so hard. And then the problem is that people often fell out of the belt, which is a tragedy too. Shock absorbing lanyards. Now the energy control lanyards will be ones that can go out and take out and dissipate the force through rip out stitching. So the fall hazards that we always see are open-sided floors. That's been around forever. Back in the 40s they talked about guarding this, and then they picked 4 foot for industry and 6 for construction. If you got any kind of hole over 6 feet or over 2 inches wide, you have to put a cover that can handle twice the weight, so you don't go into it. You're not going to go into a small hole and fit through it, but you could break your ankle or rip the tendons in your ankle. Again, ladders typically are a common cause. Roof falls are a common cause of fall deaths. And then, you can always slip on the same surface. So there are other methods to protect. I don't discuss the safety nets because they're very rarely used anymore. And that's a method too. But that would be it's a fall arrest system. You're falling and the net's going to arrest you safety. When I looked at the deaths that federal OSHA investigated in 2022, it's been the same for the last 30, 40 years that I've been doing the data. Roofs and ladders are up there every year. Some years roofs are higher, some years ladders are higher, and then it drops. Usually scaffolds has been number 3 in 2022 last year. Skylights, you saw the guards. There's over 100 guards for the skylights are now number 3. I'm really surprised because that's a change. Usually it's been like 5 or 6 deaths in a skylight, but a lot more exposure on roofs. So I tell clients, in the industry, you got to make sure these skylights are covered. I don't care if you get up there or not. If it's your building, it's your liability and risk. They make portable guardrails like this that are on 50-pound plates. Very easy to do. A unistrut, one section of this is $160. They make ladders with a podium that you stand on. So the new ladders don't want you to work two-handed anymore. So they want you on a podium or a platform ladder, as they call it. And you're not allowed to work on a ladder anymore with 2 hands on a normal step ladder. And then, of course, people fall out of the trees, and if you're near within 6 feet of the pond, you need to have a life vest on, and that's high. Aerial lifts are always in the top 10. And then we have a lot of people going down the stairs. The cell phone is the biggest detractor. You would think you would not fall down a set of stairs using a cell phone, but people actually have died from this. So we tell people, don't carry a box down the stairs, use the handrail, don't use a cell phone on the stairs, walking, everything else. So which of the following represents the correct sequence of the hierarchy of fall protection? Elimination, prevention, arrest, administrative controls, PPE. Prevention, elimination, arrest, administration controls, PPE. PPE, elimination, prevention, arrest, administrative controls. Elimination, arrest, prevention, administrative controls, PPE. So they threw a curveball in this question as they added PPE in it. What do you think? Very good. It's always going to be elimination first, and then the issue is prevention. So a little bit different in the hierarchy control. Again, people are, there's one that talks about in general we're going to have elimination. PPE is the last resort. In the fall protection, it's a little bit different, but very good. A is the answer. And then walking working surfaces, people can fall and trip and slip on ice all the time, and 100 people a year, go out and do it. Now, you saw OSHA didn't investigate a lot of those, but, OSHA only going to investigate maybe 1,800 of the 5,000 people who die every year. 2,000 are going to be on the highway and transportation, other areas like that, and then 1,000 are sole owners, so OSHA would not investigate those. So a lot of these things can be done by just keeping the area free of the ice, putting down salt or other items that can melt it, and it's pretty easy because otherwise people are walking on the ice and now you crack your head and that's a person that you're not going to replace in your plant if they die or get crippled. And if you got a standard parking lot at an industrial facility, it's maybe $500 or $1,000 to have somebody come out and salt it. The guardrail systems were made in the 50s. They picked 42 inches. Today, people are taller, so a lot of people are starting to maybe think about a third rail. It hasn't come up there, but I've seen it in some sites where they add a 54-inch rail, 42 in a mid rail. Just something to think about, because if you get somebody that's 6'6", their center of mass is over the guardrails, and if they're leaning, it wouldn't take much to go right over it. The standard is plus or minus 3 inches. You can use balusters or vertical members as long as there's no more than 19 inches of space. Wall openings is 18 inches. I don't know why we can't have one number, but we have two different numbers. They're going to handle 200 pounds downward and outward. That means you're pushing down and out. And that's not much force. That's not much force because you got to remember, this was made when people were 150 pounds. We have a lot of people over 200 pounds. And so if they stumble and hit it, you'd probably want a guardrail, it's not going to break, which is not good. And then the floral covering's got to hold twice the weight. The question is, if you got aerial lifts, does it hold twice the weight of the aerial lift? And the answer would be yes. Anything that is anticipated that's going to be in there. So plywood is strong. You get plywood, you can just make a plug, put it in the vertical hole, and you'll be okay. It's got to be secured, so the plug secures it. It's marked with a hole. You can color code it. You can use cover, but you got to have some method to protect this when it's over 2 inches in wide. So according to the standard, top rail guardrail system must be how many inches high on a standard guardrail? Very good. C. 42 inches. Stair rails, they usually have not asked this question on the test in a long time, but I just put it in here. Stair rails, the handrail is not handrails are your fall protection. So when you start to stumble on a stair, you grab the handrail, which would normally be 38 to 30 inches. It's a little bit different. It's not a guardrail. Remember, it's just something to go. So it's going to be lower than a guardrail. And if you have a stair rail, they have to be at least 36 to 42 inches. So most people put the rails, around 36 to 38, so it can service both. So where do the most fatalities occur? Roofs and scaffolds, ice and dreams. I don't know what dreams is supposed to. I have to change that. Windows and catwalks and aerial lifts. Which one do you think it is? I don't know what the heck dream is. Very good. Roofs and scaffolds. And this is a typical Yates question. We'll talk about the Yates book in a second. I'm going to stop share. The test is still referencing the second edition of the Yates book. This is a book you can maybe get online, but you do want to get this book. This is an important book to have because it's probably 30, 40 questions out of the test. So I always tell people a lot of the questions are off of this book. And it's not an easy book. It's 500 pages of, safety reading. So we have the ABCs of fall protection. We have our body harnesses are B. Our anchorage is going to be some anchorage that's going to be solid, like 5,000 pounds. And our connector, our lanyard, is the C part. The maximum fall arrest force per OSHA is 1,800 pounds. Anchorage is supposed to be 5,000 pounds. So small car it could hold. You have to inspect it. The person who uses it has to inspect it. So what I run into a lot is rust. Corrosion is not allowed on any fall component because if this snap hook spring is rusted, you're not going to see it. And if it just breaks, the snap hook stays open. Rust is common on here. When it's got this much rust on it, that means the fabric has probably been damaged by corrosion also. And you may not see this on synthetic fabrics, but it's weakened now. What are the three components of the fall arrest system? Anchorage, body harness, connecting device, hard hat, safety glasses, safety training, body harness, hard hats, steel-toed boots, body harness, connecting device, and a sturdy ladder. This one I would say would be probably 90%. Most people would get this one right. And you got to remember, the test is not there to beat you up every question. There's going to be some questions you think, wow, those are easy. Just be thankful because they're tough ones. And then the B ring is going to be worn in the middle of the back. This is going to be a common question. Not going to be worn in the front. Now, people say, what if I have a chest D-ring? Well, they do it for work positioning, but not for fall arrest. So a person's got it in the center of the back. It's worn correctly. You want to make sure that it makes, it tells you how much fall force you're going to have. He's on a restraint, which is on a track that goes onto a roof area. So he can't go off of this. It kind of is like the dog on the clothesline, I would call it. There are retractables. Again, generally you want most of your anchorages at the D-ring height or higher. The attachment body harness shall be in the center of the back, center of the wearer's lower back, the center of the chest, wearer's front abdomen. Center of the wearer's back near the shoulder level. And then the free fall. This is always on the test. And this is the hardest thing for people to understand. I mean, I want to say there's a lot of bad things on the internet about this. So I'm going to stop the camera and then we'll get into the question here. So if I've got my lanyard here, and I'm going to make this a spotlight here. And I'll put this up here. If I got a 6-foot lanyard, I'm going to wear this in the middle of my back at my D-ring. And if my anchorage is at the same height, what is my free fall? This is a simple question, but this stumps Bobby 80% of the people. If I have my anchorage at my D-ring and my anchorage is here, what is my free fall with a 6-foot lanyard? Don't overthink it. How many feet is my free fall distance? 6 feet. Very good. You're going to fall this length of the lanyard, 6 foot. it's going to move 6 foot. Then the lanyard will start to rip out its stitching. You notice this one's like a sandwich. It's got triple X's. It'll start to rip out. It takes about 600-700 pounds, and it'll rip out stitching and it'll slow you out. The maximum deceleration or rip out it can have is 3.5 feet. So the free fall distance is how far are you really going to fall? Where's the D-ring going to actually move from the vertical? Now, if I give you this question, I have my lanyard at the D-ring level. My anchorage is at 2 feet above my D-ring. How far will I fall with my 6-foot lanyard now? You'll see this wrong on a lot of examples. How far will I free fall now? Very good. Because remember, the D-ring has already got 2 foot of solid, it's not going to free fall this distance. The anchorage is up here. So you're going to fall the remaining 4 feet. If you can understand that, that'll help you a lot, because you're going to get this question all the time, and most people miss it because they just think it's always 6 feet. No, it isn't. It depends where the anchorage is. So let's share the screen again. So now we got a 10-foot ceiling height. This is what I call a noise part of the question. This means they give you data that's not going to be relative to the question. I have a 6-foot lanyard. My D-ring's at the height of 5 foot, which is a normal height. I anchor at the floor. How far is my free fall distance now? This is very difficult for most people. Yes, you cannot use them in boom blows. Well, you'll hit them, but I would just use a retractable, cut the distance out. There's the math, and then there's real life. We'll talk about that. But what is the distance? I'm going to tie to the floor with a 6-foot lanyard. My D-ring's 5 foot above the floor. How much is my free fall distance now? This is tough. Figure 11 feet. Remember, you're going to fall. Your D-ring's going to move to the floor level. That's 5 foot. And then the lanyard has got another 6-foot length. You're going to fall that 6-foot length. So it's going to be 5 plus 6 feet. 11 feet. This is the free fall distance. This is not the fall clearance. This is the free fall. So those are the 3 scenarios that you got to know. It's at the same level. It's above the anchorage is above the D-ring, or you're tied at the floor. You have to know how to do each one of them. They won't give you a math formula because it's just adding 5 plus the length of the lanyard is 6. Okay.
Hey, John?
Yes.
So, I think where I tend to go is I make an assumption, which is bad, that there is a shock-absorbing lanyard included. So if it does specifically say that, then don't include that 3.5 feet, right?
No, remember, free fall, if you read the definition by OSHA, the act of falling before the system applies the force, that 3.5 foot.
Oh, gotcha.
That's the key question, because they're always going to give you a free fall question, and that's what messes people up, and they'll ask you. Now, when we get into the fall clearance, Honeywell is one of the few companies that actually did it right. My D-ring is on a strap lanyard, so my anchorage is at the same height. I would fall 6 feet. Then we add, like you said, the 3.5 foot of distance. They will give you these numbers here. You'll think, well, that's easy. But remember, if you can't get the free fall distance, it doesn't matter if you got these 3 numbers. The height of the D-ring is 5 feet. That means the bottom of my feet to the D-ring is 5 feet. And the anchorage, the lanyard and the harness will slip up on you. It'll start to pull up. And they add a 3-foot safety factor. I had a lot of arguments with them 5 years ago, the board, when ANSI was 2 feet, OSHA was 1 foot, and another group was 3 feet. And so they finally just said, we're just giving you the safety factor. We're not going to make you guess it. So they'll just give you this question, and they'll say, what is the fall clearance? And fall clearance is the lanyard length plus the deceleration distance to the height of D-ring, the safety factor. And they'll give you these 3 numbers. But you still got to be able to do that free fall distance here. So that's that's a little bit different way to do it, but I like this chart because it's the first chart that actually was pretty good and shows it to you. And so very common on the CSP to get a free fall distance question and a free fall clearance question. Okay, this is a typical exam question that comes in. I just changed the question. The formula used to determine the free fall distance when the anchor is above the attachment point, like 2 feet above. Free fall distance equals the lanyard length, equals the lanyard length multiplied by the distance of the attachment and the anchor point. Free fall distance is equal to the lanyard length minus the distance between the attachment and the anchor point. Free fall is equal to the lanyard length plus the distance between the anchor point. Ugh. Remember, it's above your head, so it's going to be minus. Not going to add it. Remember, if it's at my feet, I would be having D. But if it's above my head, it's always subtracting it. Okay, so just remember that. You've got the lanyard is 2 feet above your head. I mean, the anchor is 2 feet above your head, above your D ring. You're only going to fall that 4 feet. It's a tough question, and that's why people have a hard time with it. And once you understand it and you've done it a couple times, then it makes sense. Leading edge. So we're going to go over here and we're going to work at the edge of it. He's got a shock absorbing lanyard. He's got a rope system. If he can fall over it, then he has to have a proper 5,000 pound anchorage. And he's wearing what they call the Class 2 ANSI hard hat, which is becoming side impact, which is what a lot of people are starting to wear. So when they get on the roofs, they use typically a rope grab system with a rope that's attached to an anchorage. And the anchorage could be from a truss or it could be from a beam, but it's not going to be just to a piece of plywood. And if you measure it right, you won't even fall off the roof. It'll be more of a restraint. But you can see this person here, he's got like 25 feet of rope. That means he might hit the ground before this thing actually stops him. Here it is, another one. You see a bunch of rope. That's not good. Here it is, it's short. He's got the work. You want to make sure you're wearing the fall protection. So if our anchorage is, again, look at this. We're going to attach to the ceiling because concrete is always a 5,000 pound anchorage. You can get anchors that drill right into the concrete or anything else. You got a long lanyard. Let's say it's a 8-foot lanyard. This is the anchorage point. This would be considered the anchorage point. And if it's 2 feet above with an 8-foot lanyard, his free fall distance is going to be 6 feet. 8 minus 2. Now when you fall with a harness, typically you're going to land like this if it's a proper harness. Then you got to get prompt rescue. Prompt rescue is not defined in OSHA, but most people know there's been deaths at 30 minutes hanging like that. So 15 minutes or half the time is what people push for. And you got to think about how you're going to get this person off. You know, people think, well, I can just pull them up, but you'd be surprised. 2 people cannot pull up an average person. I mean, unless they're got superhuman strength. It's very tough. You might be able to get them up a foot, and then your arms are not going to be that strong, unless you do this for a living. So you got to think about getting an aerial lift or a ladder or something underneath them and do that rescue. And when you get this suspension, it's called, it's suspension trauma or static intolerance. The trouble, and the people die, is the blood flow runs on the anterior femoral artery. And if that's compressed by that strap right here, that cuts off the blood flows, which is going to create blood clots, which is not good. So when the blood clots get into your heart or your brain, that could trigger a stroke or a heart attack or even kill you. So skylights, again, now number 3 cause of death. Lots of various versions on it. Again, it's got to hold twice the weight. If it's only people, you just make, I just tell people, make it 500 pounds. Alexa, stop. Which is the following potential consequence of orthostatic intolerance during fall arrest? Uncontrolled descent, suspension trauma, equipment malfunction, immediate unconsciousness. Very good. Suspension trauma. And again, all these questions, like I said, are from the exam. I changed the words. Ladder climbing devices would be a front D-ring. The maximum OSHA allows is 9 inches. So that's why you'll see a very, very short distance here. But these are fall climbing systems that are a fall arrest. It's going to arrest your fall. It's going to stop you. You're going to free fall of 9 inches. Not much of a free fall, but that's kind of nice. The safety gates, if it's more than 18 inches, they want some kind of gate. Now, they're not going to ask you this number. Wall openings at 18, and you saw the stair rails 19. They don't usually ask you, but you would look for some kind of protection, for the opening. Not that I see people fall and trip off and go down, but it does happen. And again, the ladder clearance I see all the time on these fixed ladders. They don't make them 7 foot. They put them like 3 inches, 4 inches, and you can't get your foot on, and that's why people fall down the ladders. Here's a tougher one. Personal fall arrest systems, when stopping the fall, has a maximum arresting force of 5,000 pounds or 5 times the potential energy. The employee cannot fall more than 6 feet or contact any lower level. The fall arrest system has a separate anchorage point for each employee. An employee can use self-retracting lifeline. This has got a couple answers that are very, very close. This is tough. I'm not a fan of this question at all, so don't beat it up. But this is one I would, if I was on the board, I would rewrite because it's not good. Can't fall under OSHA's 502D 16. You can't fall more than 6 feet or contact any low lever. Free fall. You don't have to have a self-retracting lifeline. You can, it can be a fixed lanyard. So that's a bad question. Fall arrest force anchorage is 5,000. Fall arrest force is 1,800. So that's, and the fall arrest system should have an anchored point for each employee, but they can be designed to hold 1, 2, 3, 4 employees if they have the multiple forces. I get ones that can handle 3 employees at one time. Somebody's done the math and said, wow, I could handle 15,000. They can be tested with a dynamometer, and there's companies, that do this for a living. But not a good question. Any questions on the fall arrest questions and stuff? Okay. I'm going to stop the share. Stop the